I can reintroduce myself. I'm cloud software architect, responsible for services in software for remote attestation. So it's like DCAP services, and I work for Intel, same as Scott.
Thanks, Pio. And Pio is one of the architects behind this platform ownership endorsements project that I'm about to talk about. First of all, big shout out to my counterpart in Germany, Dr. Benedict Fury. He put together the huge majority of this presentation, and he would be presenting, but he's been on vacation the last few weeks, so I'll be doing it for him. And he presented this at OC3 for those who are watching, but it got cut short, unfortunately, because of a power outage, if I recall correctly. So that's the other reason to bring it in here as well. And the recording wasn't available either for the same reason. So what are we talking about? I think everybody is well aware of the most recent attacks on SGX and TDX, physical attacks, and it definitely changes the threat model. There's lots you can do. There's basically the dot fail attacks are the ones we're talking about, SGX and TE dot fail. What can they do, right? With physical access to a platform, memory probing, bus observation, fault injection, cold boot attacks, of course, ciphertext observing and tampering. Those are the kind of things that we have to worry about. So a customer might trust a CSP. They might find a CSP they trust to not launch these physical attacks. They lock down the platforms, et cetera. But they have no way to really verify that platform is owned and or being held by that particular cloud provider, for example. And that's the goal of platform ownership endorsements, is to link the attestation evidence of a particular platform to that physical owner that they trust. That's the whole goal of what we're trying to do here. I'm sure most everybody here is familiar with remote attestation in general. I'll just go through the flow, if you don't mind, of how we do it for TDX. In short, at the beginning of time, what we call initial platform establishment, we have what we call platform registration phase. This blob of data from the platform is sent to Intel services, the PCS in particular, platform certification services. That the Intel services recognizes, parses and recognizes that platform, the CPU packages on that platform, and hands back what we call a PCK cert, provisioning certification key cert, that's signed by us, by our private key. On the platform during runtime, there's a piece of software called the quoting enclave. This is still right now rooted in the SGX, but it's called the TD quoting enclave. He generates a random attestation key. That attestation key is provided to another enclave called the provisioning certification enclave, which has access to the hardware provisioning certification key. He looks at the quoting enclave, recognizes the quoting enclave, and basically signs the attestation key cert and gives it back to the quoting enclave. And this is what is going to be used all the time to sign our evidence, basically, to certify our evidence. During runtime, at some point in time, a relying party, of course, is going to request an attestation of in this case, a TD, a trust domain, which is a confidential VM. He'll talk to the Intel TDX module, which is basically our trusted VMM, as it were, that will ultimately talk to the CPU hardware. The TD asks for a report, basically, of itself. And the TDX module asks the CPU for that. That report is given back and ultimately sent through the VM to the quoting enclave, who basically will look at it, verify that report, and then sign it. That turns it into what Intel calls a quote of that TD that's been signed. At some point in time, that quote will be sent or will be used and verified by some quote verification facility, part of the routing party or somewhere else. In an attestation service, possibly. That verification process will reach out to Intel and grab the verification collateral, and then do the verification of that TD, of that platform, of the whole TCB, basically. So that's the general flow for TDX attestation. So moving on to the physical attacks, what does it look like? What do these .fail attacks look like? Well, basically, They physically deployed DRAM, bus interposers, and observed memory transactions. And how is that useful, or what were they able to do? Basically, Intel SGX and TDX both use standardized AES-XTS encryption, which which means that the same plain text data if it's encrypted to the same cache line will be encrypted to the same ciphertext. So with this type of physical attack, researchers were able to basically get the PCK private key um, for the attestation process. So what are some consequences of this, right? Once they have that key, what can they do? Well, in general, they can produce TD quotes with all kinds of content, whatever they want to put in it. Arbitrary report data, this is a user defined data, and it's often used to put a public key hash in there. So you can verify that the public key being given is the public key they want to use. Arbitrary TD attributes, so they can say, "Hey, I'm not a debug TD," when actually it is a debug TD. And arbitrary measurements, MRTD, and the other measurements we have in TDX world, RTMRs. You can do all kinds of things once you can sign a quote with a real key. Because it is the real key, anybody verifying it will think it's a real quote. Of course, it'll verify correctly. One thing to note, though, once this attestation key is identified as compromised, and we've done this with both TD and SGX.fill, we can revoke that platforms or individual CPUs of a platform. And we've done that for the ones that they hacked. But before revocation, of course, and before even a relying party grabs the latest CRL or revocation list, there's no way to tell that it's a spoofed TD quote. So what are we going to do to harden this remote attestation? Well, first of all, a relying party must be able to do two things: recognize the physical owner of that machine, and of course, as I already mentioned, trust the physical owner to prevent physical attacks. So lock down the platforms, have trusted administrators, et cetera, that kind of thing. The key insight for this, the solution, is first that the attacker cannot modify that PCK cert. Again, that was signed with Intel's private key, and they won't be able to, of course, access that private key and therefore attack the PCK cert itself. And also, the PCK cert contains a unique platform identifier. In Intel's world, we call it the Platform Instance ID, or PIID. This PIID, like I said, is unique for a particular platform. It's generated randomly on the first boot, the initial platform establishment, and it survives reboots. This can be reset by explicitly performing an Intel SGX factory reset in the BIOS. So if you have to waterfall a platform or anything like that, you can do this factory reset. The PID, as well as all the platform keys for that platform, are reset automatically. And this ID is contained in multiple components that Intel uses throughout the attestation process, including that initial platform manifest used for platform registration, the PCK cert that's given back to the platform owner, and inside the quotes themselves. This ID is across all of those. And so this identifier helps us cross-reference and carry the identifier through all the relevant evidence artifacts. And so to regain trust, we want to anchor this platform ownership to something that the attacker can't tamper with, which includes the PCK cert, which includes that PIID we're talking about here.
Scott?
Yes.
One question. I read this attacker cannot modify PCK certificate, but I heard you say the attacker cannot access or get the PCK certificate. Which one of them is true?
The former. He can't attack the PCK cert. The PCK cert is available. It's part of the quote, actually.
Okay.
So it's inside the quote. It's the whole cert chain is there. So that definitely is readily available. But even if he grabs it out of the quote, he can't do anything with it because it's been signed by us.
Okay.
Good question. Thank you. Over. So for this platform,
Alec,
oh, sure.
sorry, Alec has his hand up for.
Paul, thank you. Go ahead.
Yeah, it feels like you're getting close to the end of the presentation. I'll hold my questions to the end and keep my hand up. Please go.
Oh, okay, sure.
I was just going to make a comment on the one of the slides in there, but let's just have a good discussion at the end.
Okay. So yeah, I'm just going to go through a few of the flows. First of all, the straw man flow for this, when we were brainstorming. This POE flow for us all starts, during a supply chain phase when it's being initially deployed. This unique PID we're talking about are collected from all the platforms that an owner has and sent to a repository, just a database, right? All these PIDs. In a production environment, that target platform is deployed. An attestation process is started, the quote sent to the service. He verifies that quote, first of all, but now he wants to verify, who owns the platform. The very simplest way you could do this is just retrieve that list of platform IDs and make sure that the PID inside the quote is in that list. The problem with this is, of course, that just by default, if it's just a big text file of PIDs, it's not integrity protected. And the CSP might not be willing to publish this. It could give ideas about like how many platforms they've deployed, et cetera. Something, there's information in there CSPs won't necessarily want to give out. So Intel's going about this in a phased fashion. We have a short term, a long term, and then an even longer term. We're starting right now. We've already started work on the short term process. So we'll go through this. It's similar to the straw man, but with a little more detail. Of course, starts with the PID collection sent to a platform endorser. What this platform endorser is going to do with them, stores in a database, and then creates POE structures. Now, these POE structures, what we've decided to use is the CORIM format, IETF CORIM. He'll create these structures and he'll sign them with his private key. At some point in time, again during production, attestation, the attestation service will get these keys somehow. This is implementation specific. If the CSP owns both, the platform owner owns the attestation service, he can of course just send them directly to the attestation service. If not, the platform endorser can provide a way to get them, public, API endpoint, et cetera. So again, that's implementation specific. At some point in time, again, the attestation is started, quote sent, the quote verification is done, and then also the POE verification for that platform is done as well. So that's the short term what we're thinking right now. The POE verification there at the end, of course, the flow of that is very simple. Read the platform ID from the quote, get the corresponding POE structure from the platform endorser, compare that PID with the one in the POE structure from the endorser, check the signature, make sure it's valid, and then check that the signature matches what you're expecting from the platform owner by retrieving his public key. So note that in this flow, Intel's not involved at all. This is all done by the platform owner and the attestation service. For a longer term, we want to integrate these POE structures into our existing DCAP stack, our data center attestation primitives. This is our components we give out to help people with the attestation flow. I know a lot of customers do their own, but we do provide many components, many libraries to help with this process. So the first three steps are the same. The PIDs are collected, sent to an endorser. He creates these POE structures and signs them. But this is where it varies a little bit. The POE structure is sent back to the target platform, and the target platform holds onto it. That also is implementation specific. It could be on disk somewhere. It could be just held in the host OS, something like that. Going on to the public, the production phase of the process, all the attestation needs at this point is the public key, right? So he gets the public key from the platform endorser in some manner, and he has it available. The rest of the flow is very simple. Quote and the POE structure that he held onto is sent. The attestation service can then verify the quote and verify the POE with the public key he received. So the main benefit from the short-term flow I showed on the previous slide is that the platform endorser is not involved at runtime at all. Besides, providing the public key, which could have already been done. So that's our longer-term goal down the road. We are providing tooling around this, as I just mentioned, as part of the DCAP software stack. We're doing this in a phased process too. So first we'll have this platform ID collector, extractor, as it were. It can take either a PCK cert, a quote, or a platform manifest and extract that PID for you, which will be stored. We'll also have at some point a POE generator. So it'll take the PIDs and create these POE sign structures that we talked about. And then ultimately a POE verifier, which will take a POE structure and verify it completely. Later, initially these will be standalone type tools, but they'll slowly be integrated into the DCAP stack. So like on the longer term flow, the quote and the POE structure appended, our quote validation library, QVL, will be modified to take both and evaluate both. Much longer term, we have a flow with what we call platform composition endorsements. The goal here is that a platform, of course, is composed exclusively of packages and CPUs owned by the endorser, and an untrusted maintenance administrator should not be able to get a POE for any other platform, only the ones they own. Again, this flow starts with a dedicated supply chain phase at the beginning of time, really the beginning of time, before it's even deployed. The device IDs are collected, sent to a trusted supply chain inventory database. This administrator, who does not need to be fully trusted, will extract it ultimately and send it to, let's see where my screen's not catching up. The approved device IDs to the platform endorser. Again, this is all in a very trusted supply chain manner during the pre-deployment phase. At some point in time, the target platform manifest is sent to Intel PCS. Intel PCS will look at that platform manifest, verify it, and send back a platform composition manifest, a PCM for short. And this is basically contains the device IDs that batches sends PCM back. Yeah. So this is then this PCM, which is again signed by Intel. This is where Intel is involved in this process, is sent to this platform endorser. So the platform endorser will have a whole bunch of these PCM structures which are signed by Intel, proving that owner truly does own that platform, and can be verified back with Intel. So this platform endorser will validate that PCM and create and sign the POE structure at this point in time. And sends it back again to the target platform, who can hang on to it on disk or in the host OS or some manner. Again, implementation specific for that. Going on to runtime, at this point, this attestation service again just needs the public key of the platform endorser, and the flow is basically the same. The attestation starts, the quote and the POE are sent. The quote verification is done. The POE verification is done. And the POE verification, this particular mode does the following. It reads the platform IDs from the quote, extracts the POE structure from the quote, because it's integrated at this point. Compare the platform ID in the quote with the one in the structure, check the signature of the POE structure, and check that it matches the signature that from the platform endorser. Again, after that initial phase, it's important to note that Intel does not play a role in the POE flow. So it's all on the attestation service and the target service side. We're going to have very, very similar tools for this particular flow. The initial one is called, as opposed to a PID extractor, it's a device ID collector, a processor registration ID extractor at that point. But the POE generator and the POE evaluator are very similar to the previous roles. We do have a paper talking about it. When I send out the presentation, feel free to check that out for yourself and reach back out to me with any questions or issues or thoughts. We'd love to hear feedback on this. And that's it for today. So please, I don't know who was first. I see lots of hands.
I think Alec was first one.
Yeah, I put my hand up halfway through the presentation because I wanted to be the first to say thank you for this awesome presentation and for, sharing the fact that, hey, T.fail kind of upset the apple cart a little bit on what we've been saying about confidential computing. And honestly, I think some of the statements that I've heard, at least in the field, have overstated the benefits of confidential computing. And that's terrible because if we start doing that, then when people hear the truth, they're going to want to throw the baby out with the bathwater. Let's not let that happen. There are huge benefits to confidential computing, but it doesn't solve all the world's problems. So thank you for clearing the air and helping us understand the problems that are solved by confidential computing and some of the challenges that still need to be solved and how we can solve those challenges. First off, so thanks for that. Now let me just start asking some questions. You mentioned that you could have a certificate revocation list for, attestation evidence that is signed with a stolen key. I don't think that's going to work, right? Because an attacker with hardware in hand with a memory interposer installed can mint as many or can just buy more Intel CPUs, right? And steal more keys and generate more fake attestation evidence. I think that the number of CRLs would be a factor of a percentage of Intel's production of CPUs over time. Am I understanding that correctly?
So the first thing you said, I think, was incorrect. I think you said that the PCK cert key was stolen. That's the PCK cert is signed with an Intel private key backed in our backend in an HSM. So that can't be stolen from the platform. The attestation key is the one that can be stolen first off.
Right. So
but to your point, yes, of course, they could buy more hardware, more CPUs, and keep doing the same thing over and over again. We are working, and if you again OC3, if you go back to Simon Johnson's, our chief architect's talk, he talked about that. Some of the things we're trying to do in hardware to mitigate this type of stuff, these type of attacks. But in general, I mean, yes, you can keep doing it, and we only know about it when we find out about it. We only know about it and can do anything about it once we get the key and put it on our list. But yes, that's true fact.
Okay, cool. And by the way, the gentleman you said that was Simon
Johnson.
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 And I looked for that talk. They hadn't posted it yet last week or 2 weeks ago when I think it was mentioned before. Do you know if it's been posted yet?
I do not know, but I'll take a.
Yeah, it looks like I just checked that they posted it 2 days ago.
Awesome.
I'll put the link.
Renee, do you have a link? If so, could you post it in the chat? I'm super excited to watch that.
Yeah, same here. I just saw the. Let me post the link here.
Cool. Then while you're doing that, I'm going to ask one more follow-up question, and I just want to make this clear. So I work for Microsoft, and we're very close partners with Intel, and so we've been working very closely with Intel to try and figure out how we can use this framework to prove that the hardware that's used in confidential computing is in Microsoft's possession. And my understanding of the work stream, and I'll just repeat what I think what was just given during the presentation, is Intel fabricates a CPU. That CPU is sold to Microsoft. The registration of that sort of supply chain is in, cryptographic evidence. Then when we receive that CPU, we do some sort of that firmware reset that you were talking about that shows that we have ownership of that same CPU. The cloud service provider, in this case Microsoft Azure, maintains secure inventory of all the hardware that we've purchased from Intel. And so when we flash that hardware with new firmware, we get to do one of those resets. And I think there's a limited number of resets that can be done. We use one of those resets to kind of put that hardware into operation. And then we have our own. Microsoft has its own KMS infrastructure that produces attestation evidence that Microsoft owns and is in possession of that hardware. So when a customer receives attestation evidence from TDX, included in that attestation evidence is some other attestation evidence. This evidence is endorsed by Microsoft, not Intel, that says Microsoft owns this, and we are presumably holding that hardware in a secure location where memory interposers are not allowed. So at this point, you've got the guarantees of confidential computing, where memory is private, but that guarantee is a shared responsibility between Intel, because their firmware has to be secure and not allow introspection of memory, and Microsoft, because Microsoft has to provide physical security around the hardware to make sure somebody doesn't pry the chassis off the machine and install a memory interposer. So I think that's a great bet, right? But I work for Microsoft, but I think, in the same way that you trust Intel to not make mistakes and put vulnerabilities in their firmware, now you trust the cloud service provider to not make mistakes and allow attackers into the data centers with memory interposers and all the other stuff, right, that you trust the cloud service provider for, because a memory interposer doesn't do you any good unless you know that the VM that you're trying to attack lands on a specific node in a specific rack in a specific cluster in a specific geographic location, and then you sneak into the data center with this rather massive contraption and somehow inserted into things. So some of these attacks are a little bit on the theoretical level, but I think it's a good thought experiment to understand that, yeah, you trust a cloud service provider to a certain extent, but they'd really have to go a long way to enabling that attack in order for it to affect a specific customer. So just kind of wanted to hear you comment on how that all sounds, if that's also Intel's view on how this kind of shared responsibility model works, or if you see something wrong with what I just said.
Nope, I agree with every word you said, honestly. Yes, it is a shared responsibility, and it is random, like you said. When you got 10,000 deployed platforms, how are you going to know where a TD lands, right? For a particular set of data. I don't think you said anything I would disagree with.
Well, if it was only 10,000 platforms, I would sleep a lot easier at night. It's on the order of tens of millions. So,
yep.
So finding the right rack to attach your memory interposer would be a challenge. Anyway, that's. Thank you for this. I'll go back on mute and listen to other comments.
Thank you, Alec. Nathaniel, or whomever. Sorry.
I think it was Nathaniel next.
Yeah. Who is next? I'm sorry.
Nathaniel, you go ahead, Nat.
Okay. I'm curious. I have a couple questions. I'm curious how Intel makes decisions about who counts as a platform owner and what criteria you are using to make that judgment. I'm also curious about what it means when an owner stops becoming an owner. an owner does not exist for the life cycle of the hardware, right? So if Microsoft, for example, retires a system, I'm picking on you, Alex, because your face is on my screen. That's the only reason. If Microsoft owns a system and they send it out for recycling at end of duty, right? What happens if that system doesn't become recycled? How do we know that Microsoft has stopped being the owner of that platform? And then my third question is about the sort of implicit assumption throughout this presentation that the cloud always owns and manages the data center, which they're reselling, which is not always the case. There are, even in the big three clouds, there are data centers that are leased by other parties where the cloud does not actually own the system, nor do they manage the data center that it is within. And so who counts as owner in that case? And what kind of transparency can we expect from that? So those are my three questions.
So to start with, waterfalling or sending retiring. Again, we absolutely recommend to always do an SGX factory reset. That again is going to reset the basis for this proposal, which is that platform ID that I talked about, platform instance ID. So always do that. Even if you're moving from one group to another within your same company, I would recommend that. So that resets the platform keys and it resets that PIID, which means that it wouldn't validate with the old PoE structure that someone may have access to. So it won't match up. There won't be one there. The platform owner, I mean, it goes back to what Alec was just saying. There's got to be, if you're renting out systems, like you just mentioned, there's got to be still some group trust there between Intel, the cloud provider, and whoever actually is physically running the platform. There's nothing we can do about that if there's some implicit trust there, or explicit, really, I would say. So yeah, I don't know if I answered everything.
Explicit to whom is the question, right? Because attestation is about revealing the supply chain explicitly. And if that is not part of the visibility of the supply chain, it probably matters a whole bunch.
Yes.
So, but that still raises my first question, which is, how does Intel, in the case where Intel is signing statements about platform ownership, how does Intel verify that, right? This goes back to the core CA problem, which is that a CA must never sign metadata that it cannot verify.
Well, so that's in the much longer phase. That it comes down to a trusted supply, super trusted supply chain management. In the short term and the long term flows that I presented, again, Intel doesn't have anything to do with that at all. It's really.
I was talking specifically about the long term flow, because the kind of situation I am imagining is that the sort of easy way to solve this problem, and there's no easy way to solve this problem, right? But the so-called easy way to solve this problem is basically to say, well, we sold, package X to company Y, and that therefore the signed assertion is merely an assertion about bill of sale.
Yes.
The problem there goes right back to that question I was asking about the reselling problem, which is if bill of sale goes to company A, but company A is reselling under company B, how does Intel make statements to that effect? And what happens if company B stops, reselling from company A and that platform transfers to someone else? It seems to me like a fairly thorny problem.
I agree. But we were talking about explicit trust. I think in that type of situation, the customer will trust the CSP, and the CSP has to trust whoever is actually owning that platform. Those are the flows there, right? I don't think there's a real way, and that's an interesting situation.
Yeah, that answers a question I didn't ask. That I asked a different question, which is if Intel is making a signed statement about the ownership of that platform, then and if that's based on bill of sale, then that could only be to the original seller, not to the various reselling agreements that are happening after the fact. And so that information becomes polluted, right? You end up with a lot of noise in your signal.
It's very possible. Pio, do you have any input on that
I mean,
longer term?
right. I mean, is that a hypothetical scenario? Because Intel in all those pictures, it doesn't act as, platform endorser, right?
I
It's
don't want
always
to
Um,
I don't want to jump the line here, but I think a lot of those questions that Nathaniel was asking are directed to the cloud service provider. So maybe we can divide up those questions and you guys take the ones that are specific to Intel, because you're right, a lot of those questions are not appropriate for Intel at all. But hey, I'm the cloud service provider and I've got some good answers, but I don't want to jump the line.
No, please
well,
do.
see, this is
It's true.
I wasn't asking the question of the cloud service providers, because the cloud service providers can make accurate statements about that, and they have to. The question is, when Intel starts making statements, what precisely is made in those statements, and how do we trust them?
I mean, Intel doesn't plan to actually issue any claims like that, right? Like, I sold this CPU to Microsoft, and I now issue a platform ownership endorsement. Like, I, Intel, claim that Microsoft owns that, right? It's always that physical owner, say Microsoft, that issues those claims.
But my point is, the statement that you're trying to make a statement about who manages the platform, but you're actually making a statement about who purchased the platform. And those are two incredibly different things.
What I saw
in
in
I'm
slides,
not sure. Go ahead.
yeah, sorry.
Yeah.
What I saw in the slides is that whoever claims to own the platform is making the assertion and then sending that as collateral to Intel. So if you're an attacker and you want to claim that you own a system that you don't own, that's probably not a useful attack, because I'm not going to trust, attacker-owned system. I want to trust a Google-owned system or a Microsoft-owned system.
Right.
So unless you can fabricate those assertions, there's not a useful attack.
Mm-hmm.
Yeah, my question was coming from the long-term slide.
This one here, I assume. The really long term, where we actually.
It may have been. I might just be confused about what slide I was looking at, but.
Yeah, that's the last slide. I think you had one more build on it that had 10, 11, 12 on the right side.
Yeah, the attestation. Yep, the attestation piece and the POE verification.
So it's not based upon point of sale, it's based upon registration.
Yes.
Do registrations have an expiration?
They're long lived. The PCK cert that's given back is 7 years. So yes, it does have long lived. Now, it is important to note that TCP recoveries, if you're familiar with our term for basic platform updates, including microcode, ACMs, etc., will cause this to reset as well automatically, which will, that's why we say a maintenance phase also. So it's pre-deployment and or maintenance phase. So that'll reset the PID and the platform keys as well.
Okay, so the statement is then, Intel has observed that a particular physical owner has registered a platform, and that registration lasts for 7 years.
Correct. Or until there's a TCP recovery. That platform will go out of date at that point if you haven't updated the platform and re-registered the platform.
And that would be a singleton as well, so you would not be allowed to register a platform multiple times.
No, you can. There's no limit on that. And I think there was a comment maybe from Alec that said something about our SGX factory reset being limited. That's not true at all. You can do that as many times as you want.
All right, I'll let others talk. Thank you very much. Appreciate it.
Sure. Thanks, Nathaniel. Ahmed?
I think Dan was Dan.
Yeah. So I'm curious what we can do in the consortium to help mature this, help make this adoptable. Maybe if we kind of start at one of your earlier slides, your short-term slide. There's things about the PIID and CORIM formats. We have this opportunity where we've got our CSPs and our chip manufacturers and our ISVs all in this community. And we're always looking for ways to use our time better. Are there things that jump out that we need kind of everybody to agree upon in order to make this scalable in the market?
Well, definitely go read the entire specification. That again, the link is in this presentation when I send it out. And just for feedback, we would love to have feedback on this. Again, we've just recently started, the tooling in particular. But if there's something we're missing or some, like you said, something you don't agree with or something to make it easier for adoption, we'd love to hear about that. Absolutely.
Yeah, I guess maybe what I had in mind is you need agreement from the CSPs at least as a starting point on the mechanics of this. And so we can collaborate in the open in this organization. That's kind of what it's set up to do. Right. So are there points of open collaboration here that we want to germinate a project for, or work into a working group like the attestation SIG or a separate SIG? You might not have answers for those today, but these are the facilities that we have here, and I want to make sure that we make use of them.
Okay. I'll take that back. Good feedback. Just as a note, one of the attestation SIG board members, I think that's the right term, is Jim Beanie. He's another one of the architects that worked on this, just FYI. So yeah, that is definitely a good forum to also talk about this.
Okay.
Not sure. Thank you for the feedback, Dan.
Yeah.
I have two. Yeah, I'm next. I have two questions. The first question is, what is the net addition between the short term and long term? It seems to me like Intel becomes part of this registration and proving that this is part of the CSP's ownership. What additional claims would be made when you move from short term to medium term? That's the first question.
Short to medium is really the fact that you only need the public key at runtime for the attestation service, because the target platform has that PoE structure somewhere, has stored it somewhere on its person, for lack of a better way to say it. So that's the difference. See,
I guess my question is just from a high level, not necessarily on the details on the tooling side. Why do you need Intel to be part of that claim that the CSP is owning that machine?
That's the much longer term. Yeah, that's the last flow. Yeah, it's really just you don't have to, but we're trying to provide. Again, it comes back to trusted supply chain. We're trying to help out with the trusted supply chain problem.
Got it.
That in short.
Got it. And the follow-up question I have is there any mechanism where relying parties can reach out to Intel to verify ownership of certain hardware? And I'm just trying to think out loud, if a CSP wants to retract a hardware, they would be able to do that unilaterally, right? Would Intel provide some form of transparency that this hardware was owned by that CSP at some point?
Well, that's again goes back to the longer flow, right? That's exactly what we're trying to do, is to prove that platform owner is the owner of that platform by taking the platform manifest as input, verifying that, yeah, they are the owner, and creating a signed component to give back and say, yeah, we can prove it. And Intel has said, yeah, you are the owner. That's what that flow, the last flow, is all about.
Got it. And like in that flow, right, like CSP cannot retract like that statement, right? Like cannot retract like saying I don't own like that PID wasn't like ever in my possession. Is that
They
correct?
cannot say that last question again. They can or can't say that.
They cannot retract that statement.
That they own it.
Yeah.
They can, if I understand the question correctly, they can retract it simply by doing again an SGX factory reset.
Oh, okay, got it.
I think. If I
I think like what the thing about like I think like Nathaniel and me like have alluded to this a bit, but like the transparency piece of this, right? So like the CSP connected with Intel, so like this I own like this particular platform, and now like everything is working. Is there like place where the CSP would prevent a relying party from seeing that this platform is owned by by them? And like that's like the transparency here helps, like since Intel is down like finishing that registration in the super long term like phase, then Intel has the data and like may be able to provide it like for a certain PIID.
Still not sure I'm understanding.
Okay.
So apologies.
Yeah, that's okay. Thanks for the explanation. I think next is Ofer.
Yes. Hi. One thing that I have two questions. The first one is what I'm still missing is that the POE information is injected into the attestation quote, right? So someone can read it. What prevents someone else's when they create the attestation quote on another TDX machine to inject the same POE information and claim to be who they are not?
Basically, you got to remember the quote contains a number of things, but
Right.
the two main things, it contains the PCK cert, the original PCK cert with the PID in it, and the POE structure has the PID as well. So even if they just took the POE and put it in another quote, the PIDs wouldn't match. The PIDs wouldn't match at that
Because
point.
the PID is something that the Intel software and hardware will take from the machine. Is that
exactly
the
right?
reason? Okay.
It's rooted in the CPU fuses ultimately.
Oh, okay.
Yeah, so it's part of the platform manifest that's sent to Intel at the beginning of time to register that platform, and it's in the PCK cert that's given back.
Okay.
And the PCK cert is part of the quote, and all that's rooted in hardware.
Okay. Cool. So the second question, I got that. The second question is, when should we expect to have this ability? Do we need new firmware version? Do we need new chip version? Timeline for that functionality to be there?
Well, the timeline, we're working on it. It's a short answer. There's nothing in hardware for this. This is all software.
Okay.
Besides this last slide, where there is PCS services involved.
Okay.
But for the short and the long term or intermediate term, that's all software, and we're actively working on it right now.
Okay. No ETAs at the moment.
No, unfortunately, no.
And will it be because until we have a dedicated attestation quote creation for TDX, will it also support the SGX part?
There's no reason it can't. Again, it's all part of PO. Do we? Is PO still here?
Yeah, I'm still here. Is it TDX specific? Is the question or?
No, SGX. Can you do this with SGX? And I think the answer is yes. There's no reason.
Pretty much. It's right. It's both for SGX and TDX because TDX attestation today is pretty much based on SGX.
Right. The reason is that until you guys released the attestation quote creation for TDX without relying on SGX. It will need the SGX part, right?
Correct. Okay. Alec again, please.
Yeah, I think maybe what we need here is to maybe address Nathaniel's questions. He was the one who presented a paper a while ago, or a deck, that really helped me understand how the names to identify the community that produces confidential computing. And he was the one that helped me understand that you've got, a device manufacturer. They're the ones that produce the silicon. And you buy a device that might have the brand of Intel on it, might have the brand of AMD on it. But when you buy that device, you're really trusting a bunch of folks that went into the manufacturing of that device. It might be TSMC, right? It might be the Intel wafer fab. And then those folks have KMS systems and the certs that are used to attest to the CPU ID. Those certs have to be securely provisioned. There's a supply chain for that. There's a supply chain for the firmware that goes into these devices. And then, as Nathaniel pointed out, all of that flows to a cloud service provider that takes possession of this device and who takes responsibility for operating it. So, whereas the first community of folks who are involved in producing the device and who uh, attest to the trustworthiness of that device are overseen by Intel in your case, there's a bunch of those folks, and Intel has to make sure that they're trustworthy folks. And once you hand that device over to the cloud, well, then Microsoft has to maintain a secure inventory of what all devices are in the possession of Microsoft, right? And when we lose possession of one of those devices, maybe because it needs to go out for repair or it's stolen or whatever, we need to make sure that the inventory accurately reflects that um, ch change in possession. And then when it comes back into the data center after a repair, it comes back into inventory. And when it gets decommissioned at the end of its service life, it gets removed from the inventory. So you're trusting the cloud service provider for all of that. And if Microsoft claims to possess a device that is physically located in a data center that is not within, property owned by Microsoft because it's in a data center that's rented in New York City or in Tokyo or whatever, that's still not relevant, right? If Microsoft endorses the fact that they own and operate that device, the fact that it's located on property that's not owned by Microsoft shouldn't be relevant. So I think what I'm trying to say here is we need to kind of elevate this conversation to things like that, supply chain security, possession, and secure decommissioning and stuff, and write a CCC paper at that level. And then Intel can come back and say, here's how we're meeting all of these security guarantees. And these are the ones that Intel is taking ownership of. And these are the ones that we don't want anything to do with. So you, Mr. Consumer, are responsible for verifying the attestation evidence that's providing by Intel and understanding what of the platform is being guaranteed by Intel. And then you also need to understand what pieces of that security guarantee are not owned by Intel, they're owned by Microsoft. And that way you can decide, well, I don't like this Microsoft security statement. Instead, I'll use Google's or instead I'll use someone else's. But it's not fair to put all of that on Intel because they can only control so much of it.
Yep, I agree. And that's a good idea, I think, about some type of joint paper describing all this. Absolutely.
So I've been catching some points here, and I've been beating up on my leadership here at Microsoft, and this is more for the TAC chair's benefit, I think, than for anybody else. I've been beating up on my leadership here at Microsoft that, hey, we need to get back into the business of authoring white papers that describe what the heck is going on because we're getting really good. I think the outreach committee has done a good job of spreading the word of confidential computing, and now we're getting some really hard questions from some really sophisticated folks who are interested and want to make sure it's real. And right now the answers are here in the TAC, but they're not written down anywhere on the CCC website. So we need to get busy on that. So I'm trying, Dan, and I think we should, as a TAC, try and get to that.
Yeah, that sounds great. And I was kind of thinking about like what could be some other next steps at the CCC. And Scott had those 3 new tools on one of the slides. That was the PID extractor, the POE generator, and the POE evaluator. So the first of those feels very Intel specific, but the other 2 feel like, hey, we need a general purpose POE verifier for this scheme to work. Kind of seems like a good CCC project.
Agreed.
Okay,
Hey,
well,
Nathaniel,
thank you.
I'll call out to you, Nathaniel. You had that deck. It was a Google Sheets thing from memory. I've looked all over for that darn thing because I know you sent it to me, or maybe you just shared it with me on the screen.
Yeah, it was from a prior employer, so I no longer have access to that deck. But
Fiddlesticks.
I still think everything that is there is true, and we're fundamentally dealing with that when we talk about attestation. We're fundamentally dealing with runtime supply chain and all of the different parts that go into to make that supply chain. And that supply chain has to be extensible to all of the lower parts of the supply chain. And it has different parts of the process with different properties. So, for example, you've got the hardware manufacturing process and all the bits that go into that. You've got a firmware manufacturing process, all the bits that go into that. You have physical asset management, all the bits that go into that. You've got guest operating systems, and those are getting decomposed. Each of those has different properties, and we can't presume that the properties that work in one part of the supply chain also work in another part of the supply chain. So one of the unique properties of what this concept of platform ownership is that platform ownership, can it certainly has a lifetime, and that lifetime needs to be captured. It certainly has creative ownership arrangements where who owns the system and what counts as ownership is something that's not well defined by the industry. And in fact, I am personally aware of at least one major cloud contract in which there are 2 levels of indirection. So company A owns and manages the facility, resells to company B, and then resells to cloud C. So those types of arrangements have to be accounted for in this concept of platform ownership. But each part of this supply chain has different properties, and each of those properties needs to be accounted for.
All right. Well, I think that might be a good last word on this topic. Thanks, Scott, for presenting, and pass our thanks along to Piotr, who's dropped.
Thank you for the time.
Dan, do we want to cover now like the
Yeah, so with our remaining time, we've got
yeah
the white
Doctor's
papers
use.
that we are working on. So like Alex saying, we got to get back into the business of generating these. So we've got 4 of them in flight. Well, 3 maybe in flight and a 4th in the wings, waiting to get onto the tarmac. One of the open questions we had across these papers is, can we mention commercial products? So we've got a imprecise answer that we got back from the Linux Foundation. Well, they may have given a precise answer, but I'm going to give you an imprecise telling of it, which is that if a product is using one of our projects, that's fair game. I think it was implied we shouldn't endorse that product. But if you had something that was, say, downstream of NARCs, let's say, just for sake of argument, you had productized that, one of our ISVs had a product based on NARCs, then that's something that we can clearly mention. Something that's probably in a gray zone is that a lot of what we do with confidential computing is upstreamed in the Linux kernel. And so in a way, a lot of our stuff is downstream of that. I don't know if that's crossing a line or not. But I think it's worth us putting careful mentions of existing solutions into these papers so that potential adopters can find them. And we just need to make sure that we're not doing obviously incorrect things like overtly endorsing one product over another. So if we can get those into the papers generally, I think that'll make them more useful. And then we can have, if that does cross some line in a Linux Foundation policy, then we can always cut them back out. But I'd like to see us put them in there to get started.
Is there a way to get it in a kind of writing so we could look at that and ask questions? I think that it's, as you said, it's quite vague. It's like walking between the drops. And
yeah. We will. I can't remember off the top of my head if the note that I got back said like we'll get you something soon, or if it was what exactly it said. So that's kind of where it was in the gray zone with us today.
So does it mean that we're waiting for their final verdict in a way?
Well, let me see if I can pull up the exact thing. But I think the takeaway, so that we're not watching me try to search through my email, is that it's okay to mention things that are based on CCC projects. It's a little bit less clear whether we can mention things that are based on Linux Foundation projects generally. I would assume that's true. And I just don't know if the Linux kernel is too far a degree removed that we can just kind of claim reliance on that. So my guidance for today is let's put conservative mentions of projects in that demonstrates the use cases that we're trying to explain in these white papers.